What's up? Nice to have you back here on this channel. In this video we're going to talk about the Mandelbrot set and how to use the pixels array from the last video to set the color of each pixel individually according to the Mandelbrot set. Let's do this. So I'm here on the Wikipedia article of the Mandelbrot set, and the Mandelbrot set is basically a subset of the complex plane, and the definition is basically written over here, which is a value set on the complex plane is part of the Mandelbrot set if and only if this sequence of values is bounded. So that basically means we have this sequence z0 0, then we get the next ones iteratively with squaring the last one and adding this number c, and then we say the Mandelbrot set is basically defined as all these values c, such that this sequence the supreme, so the sequence is bounded, which is the supremum of all the elements. The absolute number of the elements is smaller than infinite. And yeah, so we look at in the complex plane. If we, for example, take the number 0 as the c value, then we start here with 0. We make 0 squared plus 0, so if we take z equals 0, for example, which is this middle point, then all the z ends are 0, and then yeah, we are bounded, so 0 is part of that, so that's kind of the trivial solution. And then we will look at values nearby, and it's actually shown that this is the case if and only if the supremum is smaller than 2. So whenever this sequence for some choice of c, we can choose now any values in this complex plane, and if this sequence passes this value 2 when in absolute number, then actually it will not be bounded and will not be part of the Mandelbrot set. So we're actually looking for numbers in a kind of a range about 0, and yeah, let's code that. I'm back in the P5.js web editor, and we will again use the complex number package of the math.js library. And for that I'm in math.js.org and go to download, go here to this one, first one, maybe the second one. Yeah, this one is good, and we're looking for some kind of script tag. Copy that script tag, and we pass it here into the HTML file to the scripts, and so we are ready to use and to import the math complex library, and I save it into this variable c. So let's start our little project here. I want the size of the canvas to be the window width, the window height, and set it here as this, and here this one. So in the last video I talked about the pixels array and how to use it to manipulate pixels individually on the canvas, and we will use that one as well. We will again set the pixel density to 1, which basically means that we really access each pixel in the canvas individually. And I copy the code of last videos, the code of the last video, which is basically if you want to set the color of a pixel with the coordinates x and y, and we want to set it with this color, it will actually calculate the index in the pixels array. The pixels array is this object right here, and it will calculate the exact index where to actually manipulate the pixels array according to these coordinates. We can see that x and y are inside here, and then we can actually set in the pixels array at these 4 spaces, which is the red, green and blue, and alpha value of this color we are passing. If you want to run some for loops, which is we want to access all the rows and the columns, so actually I start with the column, kind of the x value, and I go as wide as our canvas x size, which is the real part of this number here, right here. And then I will also loop over the rows, which is this one. And yeah, we at some point want to draw a pixel here at yeah, this position. At the x position is the column, the y position is the row, and we want to add some color. And if we, for example, set this one to white, then we should already see actually what we have to do when we're using the pixels colors, the pixels array. So whenever we want to use this pixels array, sorry, I should turn off the auto refresh, because if you leave that one on, it will always auto refresh if you save your code, but if it's not ready to be rendered, then it can cause some slow. So it's causing it right now. So yeah, be aware of that auto refresh button. Usually keep it off. It's just some cases you want to turn it on if you really want it to be update the canvas to be updated in every saving or any code change. But now I don't want that, and I actually have to load the pixels, so I can actually access the pixels via this array. And whenever I use draw pixel, I have to update pixels. I have to call update pixels, and that will actually make the change. And so if I press play now, we actually should see a white canvas. We do not. So what's the problem here? Yeah, the mistake is here. I copied the code, and that's usually a thing to think about always when you copy code. Be sure that it's in the right format, so to say. So here I want to have the number of pixels in x direction here, and in this case it's the real part of that complex number right here, of the size number here. And another thing we have to do here, if not the code will be very slow, we do not want to loop the draw method. We just want to execute it once. We want to draw the pixels once and then see a nice outcome, because if we loop that, it will be very costly in time, and it will be very slow. So if I press play, we can see that the pixels get now updated with the color white on all pixels, basically, because I'm here iterating through all pixels, basically. So in x direction all, in y direction all, and setting all pixel values to white. Yeah, now we actually want to do something with these pixel coordinates here, because the pixel coordinates will stand for some complex number in the complex plane, and for this complex number we want to evaluate whether it's part of the Mandelbrot set or not, and therefore color it accordingly. And for that, we in the last video as well, with the pixels array, we use these two functions where we map a complex number to, or here let's start with that, where we map a canvas coordinate to the complex number and a complex number back to a canvas coordinate. So we have to always actually, that was in the video of zooming and dragging, so we have to always keep in mind that the canvas has its coordinates, which is from 0 to size the size x and size y, basically, according to this size variable here. That's the canvas coordinates, but the underlying behind world, so to say, the complex plane in the back, has on these places where we have on the canvas coordinates, we have some complex numbers, and they have their own value. They don't follow the exact values of the canvas, maybe. So we have here two distinct coordinate systems, basically, and with these mappings we can map in between them. We just have to say what is the center of the complex plane, of the window through the complex plane we're looking. What's the width? What is the height of that complex plane we're looking at? So I described all of that in the zoom and dragging video, where I looked at that deeper. So with these three values, which we also have to initialize, so we just say the center of the complex plane is 0, 0. The width is let's say the height is 6, I think it was a good thing, and the width is actually the width is 6 and the height shall have the same. So the width is the real. Yeah, I want to multiplicate with w, so we have to do that. We want the height divided by the width of the complex plane shall have the same ratio as the canvas ratio, so to say, canvas size, the canvas y size divided by the canvas x size. So the canvas ratio is the same as the complex window ratios. We have the kind of the same format here. So if we do that, we can now map in between the canvas and the complex world, so to say. And now what we can do is actually we can give us here a complex value, which is we take canvas, how did I call that? Map canvas to complex. So I take canvas coordinates and want to get the complex number, and now we want to see is complex in Mandelbrot set, and if it is, we want to fill it with a certain color. If it's not, we want to fill it with another color. So for that we want to write a function which gives us the result of whether a complex number is part of the Mandelbrot set or not. Is part of or is in Mandelbrot set. So we take a complex number and do something with it, and we want to code that definition of the sequences of these kind of Mandelbrot set sequences. We want to see if that sequence at some point gets too big, which is actually, if it gets bigger than 2, then we already know that it's cannot be part of the Mandelbrot set. So what we want to do is now define that, which is basically have a sequence which starts with 0, and we want to loop some times over that. So let's loop 10. Let's loop 20 times. Maybe we don't have to move that often. Oh, let's move a bit less. Let's loop 10 times. So 10 times we'll now execute that. We will calculate the next, which is z equals, we multiply z with itself and add this complex number which we gave here to the function. So that's basically the definition of the sequences, and whenever the absolute value of z gets bigger than 2, we can stop all of that and say no, this z cannot, but this number complex basically cannot be part of it. And if this doesn't happen in 10 iterations, then we say okay, we can more or less confidently say that it is part of that. Of course that would be wrong in some cases because we're just looking at 10 iterations, but yeah. So it will be part if it does, after 10 iterations, does not pass the 2 absolute value of 2, and if it does pass it, if it does go over it, so we then can confidently say that it's not part of the Mandelbrot set. So what we can do now is we say if is in Mandelbrot set this complex number I calculated here, if it is part, so if it is in the Mandelbrot set, I want to color it black, and if not, oh sorry, we have to define a color variable here, which I just say color. We say color shall be color 0, and if not, so if it is not, we want to color it white just for this one, and then we pass this color to this draw pixel. So what should happen now is we loop over all the pixels, we calculate the complex number behind that pixel coordinate, the canvas coordinate. We see if that complex number is part of the Mandelbrot set or not. If it is, we will render this specific pixel to be black, and if it is not part of the Mandelbrot set, we render it white, and then we draw the pixel, update the pixels, and we will hopefully see now something nice. Okay, we get a problem here. So I use this multiplication function for z, as I initially set as 0, but it has to be a complex number, so we have to do this. So z has to be complex number so we can use that stuff. So we have another problem here. And again, I copied functions of another code and did not adapt it. So for size x, I have to write size y, for size x here as well, and for size y, size x, size re, and size y, size im. So let's see if this works out now. Still not. So this is having some problems with this variable name. Maybe I will actually choose now this, because I have col for the col here. I don't think this should be a problem, but let's try that. Still doesn't like that one. I think we should, okay, it's right here. I entered a 0, has to be an O. Okay. So this is now calculating, and we can see some kind of Mandelbrot set. So this is already a very nice result. And now, of course, we can do a lot with the coloring. You see, we can see that the edges are really round, and they're very kind of not sharp, and that's because of this iteration thing here. So we can actually set that a bit higher. So let's set it to 100. And yeah, setting it higher, we can see that it's much finer, even too fine. We're actually a bit far away of it, so we can just very comfortably just set the width a bit less. So let's set it to 4. So just how to understand that center, width and height. The center basically means is which complex number shall be in the center of this rectangle we're seeing right now. So we have the canvas here with its canvas coordinates, but the center as a complex number here right now is 0, 0. The width shall be 4 in size, and the height according in the same ratio according to the canvas, which will be kind of 4 as well, because it's nearly square, right? So yeah, this looks really nice. Let's go a bit nearer again. Let's see if we just put it to 2, but we should a bit near now. We should be a bit near, and yeah, we can see stuff. Yeah, but for these lines, we have some isolated points that should not happen. But yeah, that's because of the numerics basically here, and the pixel sizes are maybe too big still. So 1 pixel is still too big to actually show all the details. If we want to color that a bit more interesting, we can use some different concepts here, and I will code that, explain to you what else we could do now to color all that a bit more interestingly. So yeah, what I did now is actually that I don't use only a function where I calculate whether it is part or not of the Mandelbrot set, but what I'm actually interested in is how long it takes to pass some certain value. So this will kind of give a clue of all numbers which are not part of the Mandelbrot set, how long they actually take, and then if the more near they are, the less they tend to take. But that's not completely true neither. But what we're actually doing is I defined a iter variable which I set to 100. I will iterate here in this one, and this Mandelbrot set function here, and this new function, and whenever it passes some value, which I set a bit bigger than 2 now, maybe to 20, whenever it passes that one, I want to return the number of iterations it took to pass it. If it never passes it in iter, I will basically return iter, and which says that it didn't pass basically. And then here, and when setting the colors, I will actually say so I will actually calculate that Mandel value, that iteration value for this complex number. I calculated here with map canvas to complex, and if this Mandelbrot value is equal to iter, so it never actually it never passed the 20, so then I would color it black. And if it did it before, then it's outside, and I want to kind of lerp color here and color it a bit differently. So let's see how this looks. So yeah, I actually had a little mistake here. I just had lerp without the color, but I need to write the color as well, because we're lerping a color, not only number of values. And yeah, when printing this, we can see this kind of shades. I don't know if you can see that, but we have to actually yeah, we have to make that more clear, and that we can do that, for example, by making these values a bit smaller. So I will power that to write that one here as well. So yeah, we have to twist stuff here to get some more nice stuff, and we can see now a bit better shapes and really looks nice. Actually, I should write this color here, and then it will go from white to black. So it will be black in the middle, and it will go from white to black from the, yeah, that looks very nice now. So we are black in the middle, so that stands for all the values where it didn't pass 20, because it's part of the Mandelbrot set, it will never pass 20. So all these ones in the middle will be called 0, so black, and the rest will be going from black to white, which is their white very near the border, because they took many they took many iterations to pass the 20, so this Mandel value is near the iter value, and so that makes this value here and a value near to 1. So it's kind of, this lerping kind of goes from white to black, from the edge of the Mandelbrot set out. So that's a really nice result, and you can really test out different colors, different values here. But that's a really nice result, and yeah, I did some different colorings and put them in Instagram. You can check them out if you like. So if you find my Instagram account in the description of the video. So that was it. I hope you had fun and you learned a lot. The Mandelbrot set is really truly beautiful, and it's really mysterious. You can see many nice zoom videos in YouTube. Just put in YouTube Mandelbrot Set zoom, and it's really amazing. This set is very amazing actually, if you zoom in and see what patterns lie in this zooming in world of the Mandelbrot set, and it's really weird somehow, and very inspiring, and tells something about this nature in this world. And yeah, I hope you had fun. I hope you could learn something. I did, and I had a lot of fun. See you next time. Thank you for watching, and yeah, see you next time. Ciao.